Hello, geometry class. We're going to keep working on the area of some figures. The first figure we have today is a circle. Now, the circle you guys have been looking at for a long time now, since middle school, the area of it, so it should be pretty easy. Our circle, the area, is equal to pi times the radius squared. Pi. You guys have noticed, hopefully in the room, from the numbers you made from earlier this year, we have pi going all the way around the room. It is an irrational number. It goes on forever and ever and ever. Probably know better as pi is equal to 3.14, which is good. But you should also know that pi is actually equal to the circumference of a circle divided by its diameter. So all the way around the circle divided by the diameter going through the circle. This works for all circles, big, small. The circumference over the diameter. All right, one other thing about circles that we should know is what the circumference is. There's also a formula for the circumference. So the circumference of a circle, I'll call it C, is equal to 2 times pi times the radius. So we have two formulas for circles. Area, which is equal to pi times the radius squared, and circumference, which is equal to 2 times pi times r. So our radius is halfway through our circle. Let's say in this circle we have a radius equal to 3. My area then is going to be equal to pi times 3 squared, which is equal to 9 times pi. Now we can leave our answers in terms of pi, like this, 9 pi, or we can go ahead and multiply 9 times pi. If we multiply 9 times pi, make sure you use the pi button. It'll give us a little more accurate answer. So we hit 9, and then times, and our pi button is located down at the bottom left corner. So we hit pi, and we get 28.27 for that. Circumference then is going to equal to 2 times pi times our radius, which in this case is 3. So I could say my circumference is equal to 6 pi. All right, moving on to a little more difficult topic, is the area of regular polygons. So this polygon, remember regular polygons have the same length all the way around. So this is a 5-sided polygon, making it a pentagon, and it has side lengths of 6. So we could write 6 all the way around here. So the perimeter would be 6 plus 6 plus 6 plus 6 plus 6, which is equal to 30. Remember, the perimeter is all of the sides added up together. In this case, we have 5 sides. We multiply that by this distance of 6 of each side to get a perimeter of 30. We're going to use that perimeter later. So polygons we can break into other shapes that'll help us find the area. So if I make a dot right about the center of my polygon, I can make my polygon into triangles. And if this is perfectly the exact center, all these triangles will be the exact same. So if I can find the area of one triangle, I can find the area of my whole polygon. So we know that this bottom side is equal to 6. But for the area of a triangle, you guys know that we need to know this distance here. We need to know the height. And in a polygon, this height here, we use the letter A for it. And it stands for the apothem. The apothem is the distance from the center to a side. So we could draw apothems in each of these triangles if we wanted to. I'm just going to do it for one though. So it's the height of our triangle. So we need to figure out what this apothem is in order to figure out what the height of our triangle is. Now, since each side is 6, I could say this side is equal to 3. Still not going to quite give us enough information, though. We're going to use something that we learned a little while ago, our good friend SOHCAHTOA. Never forget SOHCAHTOA. It's going to haunt you for the rest of your high school. So the way that we're going to use SOHCAHTOA, you guys should be saying, well, there's no angles here. How are we going to use SOHCAHTOA? The way that we're going to use SOHCAHTOA is we have to find what some angles are. So if I want to know how many degrees it was all the way around there, you guys should know that there are 360 degrees in a circle. And if I broke this into 1, 2, 3, 4, 5 different triangles, I could figure out what each angle here is. But I don't want to know that angle. I want to know, switch colors here, I want to know this angle here in my right triangle. So there are 10 of these size triangles in this pentagon. Note that it'll depend on the number of sides we have in our figure, what we're going to use. So it's 360 degrees all the way around, and we have 10 of these little angles all the way around my pentagon. So if I divide 360 by 10, I get 36 degrees. So this angle is going to equal 36 degrees. Now I'm going to use my good friend SOHCAHTOA in order to solve for A. So I'm going to use 36 degrees, making this side 3, the opposite side, and this side A is my adjacent side. So which one uses opposite and adjacent? You can look over here at SOHCAHTOA and see that tangent uses opposite and adjacent. So the tangent of 36 degrees is equal to the opposite over the adjacent. Now I have a variable in the denominator, and we should know by now I need to get it out of the denominator. To do that, I multiply both sides times A, and I get A times the tangent of 36 degrees is equal to 3. Then we divide by the tangent of 36 on both sides to get A all by itself, and I get A is equal to 3 divided by the tangent of 36. I'm going to use my calculator to find that out. So 3 divided by the tangent of 36 is equal to 0.38. So we got 0.38 for my A. Now that looks a little bit small to me for it to be 0.38. So what did we do wrong? We can check our math. I don't see anything wrong with the math. Maybe my calculator is in the wrong mode. So let's check that. If we go to Documents, and number 7 there, Settings and Status, and Document Settings, yep, I am in radians mode. So we need to change that to degrees. We'll make that the default. Hit OK. If I hit enter again, now I get 4.3. 4.3, that looks a little bit better. 4.3 for my angle A there, sorry, for my side A. So we're not done yet. We're trying to find the area of this. So this is quite a long process. We found the apothem, but we need to find the area. So I could find the area of this triangle, which would equal to 1/2 base times height. So 1/2, the base of this triangle is 6 times the height, which is 4.3. So 1/2 times 6 times 4.3. So 1/2 times 6 times 4.3 is equal to 12.9. So the area of that triangle is equal to 12.9. Now I have 5 of those size triangles in my pentagon. So if I multiply that by 5, I can get the area of the whole shape. 12.9 times 5. And I get 64.5 for the area of my shape. I don't know if you notice or not, but we have a formula right here. Area is equal to 1/2 small a p. So change my colors up here. Let's see what that does. A is equal to 1/2 small a times p. Now my small a is my apothem, which in this case we figured out was 4.3, times p is my perimeter. Figured out earlier the perimeter is equal to 30. So 1/2 times 4.3 times 30. Let's see if that gives us the same thing. 1 divided by 2 times 4.3 times 30. And that's equal to also 64.5. All right. I'm going to conclude that for the lesson today. In class, we'll practice this some more. Always when we're trying to figure out the area of these polygons, we're going to end up using SOHCAHTOA. So don't forget that. We'll see you in class.